Stars change in the universe. Stars are complex and dynamic objects that undergo a variety of changes over their lifetimes. In this article, we will explore the different ways that stars can change and the factors that contribute to these changes. Stars begin their lives as clouds of gas and dust that collapse under the force of gravity. As the cloud collapses, it heats up and becomes denser, eventually forming a protostar. The protostar continues to heat up and become more dense until the temperature and pressure in its core are sufficient to initiate nuclear fusion. At this point, the protostar becomes a star and begins to shine. Once a star has begun to fuse hydrogen into helium in its core, it enters the main sequence phase of its life. This phase lasts for the majority of a star's lifetime and is characterized by a stable balance between the inward force of gravity and the outward force of nuclear fusion. Stars in the main sequence phase have a relatively stable luminosity and temperature, and their properties can be predicted based on their mass. As a star ages, it begins to run out of hydrogen fuel in its core. This causes the core to contract and heat up, which can cause the outer layers of the star to expand and cool. This expansion is known as the red giant phase, and stars in this phase can be up to hundreds of times larger than they were in the main sequence phase. The outer layers of the star also become much cooler, which can cause the star's color to shift from blue to red. Eventually, the core of the star will become hot and dense enough to initiate the fusion of helium into heavier elements. This causes the star to shrink and become hotter and more luminous, entering a phase known as the horizontal branch. This phase is relatively short-lived and is followed by the asymptotic giant branch phase, in which the star again expands and cools as it runs out of fuel. The final fate of a star depends on its mass. Low-mass stars, those with a mass similar to or less than that of the Sun, will eventually shed their outer layers and become white dwarfs, small, hot, dense objects that gradually cool over billions of years. Higher-mass stars, on the other hand, can undergo more dramatic transformations, such as exploding as supernovae or collapsing into neutron stars or black holes. In conclusion, stars are complex and dynamic objects that undergo a variety of changes over their lifetimes. These changes are driven by the amount of fuel the star has, as well as its mass and composition. The study of stellar evolution is an important area of research in astronomy, providing insights into the origins and evolution of the universe as well as the potential for life beyond our own planet. Novae occur when a white dwarf star in a binary system accretes material from a companion star. As the material accumulates on the surface of the white dwarf, it can trigger a runaway nuclear reaction that causes a sudden increase in brightness. This process can repeat multiple times, leading to a series of explosions that can eject material into space. Supernovae, on the other hand, occur when a massive star runs out of fuel and undergoes a catastrophic collapse. The outer layers of the star are blasted into space in a massive explosion, while the core collapses to form a neutron star or black hole. Supernovae are among the most powerful explosions in the universe and can briefly outshine an entire galaxy. Black holes are perhaps the most extreme outcome of stellar evolution. They are formed